In the previous video, we discussed the conditions that allow for a gas to exist as ideal. Before that, we reviewed important ideas about pressure, volume, and temperature. But how do they relate in ideal gases? The pressures, volumes, and temperatures of ideal gases have a mathematical relationship to each other, which we can describe with a couple different laws, and an overarching law that will encompass the rest. First, there's an inverse relationship between pressure and volume. In other words, as pressure increases, the volume decreases. As pressure decreases, the volume increases. We can understand this using the definitions for pressure and volume. If we increase the volume of the container of the gas, we increase the amount of area that the gas exerts its force, thus decreasing the pressure. This law is known as Boyle's law. Second, there's a direct relationship between temperature and pressure. As temperature increases, there's an increase in pressure. As temperature decreases, there's a decrease in pressure. By increasing the temperature, we increase the speed at which the particles move, thus increasing the force that they exert on the area, and increasing the pressure. This law is known as Gay-Lussac's law. Finally, there's also a direct relationship between temperature and volume. As temperature increases, there's an increase in volume. As temperature decreases, there's a decrease in volume. We can understand this similarly to the previous law, showing that as temperature increases, molecules move around faster, allowing for more space between them, and thus more volume. This law is known as Charles's law. You don't have to take the time to remember each law. There's actually one single law given to you on the reference sheet that encompasses all three individual laws. The combined gas law describes the combined relationship between Boyle's, Charles's, and Gay-Lussac's laws. When given all three values, we can solve for a missing value on either the left or the right side just by algebra. It can also help that if one of the values, like pressure, remains unchanged, we can simplify this equation by just erasing it from both sides. For this law, it doesn't matter what unit you use for pressure and volume, as long as the unit is identical on both sides. However, you need to use Kelvin for your temperature. We can also relate pressure, volume, and temperature to the number of particles of gas, or marbles, the example I used in the previous video. Avogadro, a scientist also responsible for one awesome thing we'll talk about later, stated that ideal gases with the same pressure, volume, and temperature will have the same number of particles. This is known as Avogadro's law. In the next and last video of Unit 1, we'll wrap up with understanding how gases can move, as well as how combinations of gases can affect certain properties.